Dear students, in the previous lecture I have discussed about the newsbuy problem. In the newsbuy problem we have considered only one period of the cycle, inventory cycle. In this lecture we are going to consider multi-period order quantity reorder point model with the probabilistic demand. So, the difference is in the previous lecture we have considered only one period, now we are going to consider multi-period, and here the demand is going to be probabilistic. So, the agenda for this lecture is multi-period order quantity reorder point model with the probabilistic demand. You remember in the beginning of my this topic on inventory management, I have shown what are the assumptions which we have followed. This is for traditional EOQ model. What are the assumptions? What are the assumptions? Demand D is deterministic and occurs at a constant rate. So, this assumption is violated. This model which I am going to discuss now, here the demand is not deterministic and it is a multi-period. Like that there are 7 more assumptions, all other assumptions are valid. For example, the order quantity Q is the same for each order, that is okay. The inventory level increases by Q unit each time an order is received. The cost per order is constant and does not depend on quantity ordered. The purchase cost per unit C is a constant and does not depend on the quantity ordered. The inventory holding cost per unit time period CH is a constant. The total inventory holding cost depends on both holding cost and the size of the inventory. Shortages such as stockouts and back orders are not permitted. The lead time for an order is constant. The inventory position is reviewed continuously. As a result, an order is placed as soon as the inventory position reaches the reorder point. These are the 8 traditional EOQ model, these are the 8 assumptions. The model which I am going to discuss, the first assumption, the demand is deterministic and occur at a constant rate, that assumption is violated. So, inventory model in this lecture is based on the assumptions of the EOQ model shown in the previous slide, with the exception that the demand is probabilistic rather than deterministic. Look at this, in x axis there is a time, in y axis it is inventory, there is a reorder point is there. You see the demand is not constant, it is probabilistic. As soon as the Q inventory is over, again we are going to order, but the order replenishes instantaneously. The Q is the ordering quantity. This is our reorder point. Sometime there is a chance, since the demand is probabilistic, there is a chance there will be a stock out. Okay. So, this problem we are going to consider in this lecture. In the previous lecture we considered a single period inventory model with the probabilistic demand, that is what we have done in the newsbuy problem. But in this lecture we extend our discussion to a multi-period order quantity reorder point inventory model with the probabilistic demand. In the previous lecture we did not talk about the reorder point, and in the previous lecture we have considered about only one period, but now we are going to consider multi-period and we are going to consider reorder point. Sometime there may be a stock out also, and the demand is probabilistic. So, in the multi-period model the inventory system operates continuously with many repeating periods or cycle. So, inventory can be carried from one period to the next one. In the newsbuy problem, that was not the assumption, inventory cannot be carried. So, here assumption is that what should be the Q when we have to make the order not without minimizing the stock out. And one important point I wanted to say, since the demand is probabilistic, there is a chance for stock outs. Here what we are going to do here, we are going to order quantity Q so that the number of stock out is minimized. That is the basic idea behind this model. So, whenever the inventory position reaches the reorder point here, for example, here whenever the inventory position reaches the reorder point and order of Q unit is placed. So, we are making this Q unit because the demand is probabilistic. The time the reorder point will be reached, the time between orders and the time order of Q units will arrive in inventory cannot be determined in advance. So, since the demand is probabilistic, it is very difficult to say the time the reorder point will be reached, the time between the orders, the time the order Q units will arrive in inventory. So, these things cannot be clearly predicted in advance because the demand is probabilistic, uncertain. Note that the increase and jumps in the inventory occur whenever an order of Q units arrives. You see that? Suppose we arrived this is not the see there is a jumps. Previously it was a straight line like this, but now there is a jumps. So, the inventory decreases at a non-constant rate based on the probabilistic demand. You remember previously the assumption for demand is decreases at a constant rate. Now, the demand is decreases, inventory is decreases, not the demand, the inventory is decreases at a non-constant rate. A new order is placed whenever the reorder point is reached. For example, whenever the inventory reaches this point, we make another order. So, that point is the reorder point. At times, the order quantity of Q units will arrive before inventory reaches 0. Okay. So, what will happen? This Q unit may arrive before it reaches the 0. You see here, before it reaches we have started to order, reaches the 0. However, on other times a higher demand will cause a stock out before a new order is received. See this situation where there is a chance for stock out. You see here for example, this category. So, this point you see that even the inventory before it reaches we are making the order. Here also see this point, before the inventory reaches 0 we are making the order, but you see the last one there is a point that we may end up with the stock out also. As with other order quantity reorder point models, the manager must determine the order quantity Q that the order point, that is the reorder point R for the inventory system. So, here also we have to specify the reorder point. Remember in the newsboy problem we did not discuss about the reorder point because this method is this model is multi-period. So, here we need to specify the reorder point for the probabilistic demand. So, I will explain the concept with the problem. The reference for this problem is Anderson et al. Book. Let us consider the inventory problem of a distributor who purchase from a well known manufacturer. There is a distributor, he buy from the manufacturer. The distributor would like a recommendation on how much to order and when to order, so that a low cost inventory policy can be maintained. So, the distributor is making order to the manufacturer. So, we have to suggest how much to order and when to order. The pertinent fact are that the ordering cost is $12 per order and he is purchasing the light bulbs, there is a distributor. So, one bulb cost $6 and the distributor uses 20% of the annual holding cost rate for its inventory. So, what will be the annual holding cost? The percentage interest percentage, say 20 multiply unit cost 6. So, this will be $1.2. So, the distributor which has more than 1000 customers experiences a probabilistic demand. In fact, the number of units demanded varies considerably from day to day and from week to week. The lead time for a new order is 1 week. So, historical sales data indicate that the demand during 1 week lead time can be described by a normal probability distribution with a mean of say 155. Here the mean is 154 bulbs and a standard deviation of 25. So, this was the lead time demand, because what is the lead time demand? The lead time demand is following normal distribution whose mean is 154 and standard deviation is 25. Because the mean demand for 1 week is 154, that is a lead time demand 154 units, the distributor can anticipate a mean or expected annual demand. How much? So, there are 52 weeks per annum and 1 week demand is 154. So, the annual demand is 8008. In some other books for multi-period probabilistic model, there is a very detailed mathematical models are presented, but in this lecture we are going to do a kind of a approximate method. So, this approximation method will provide you the better result, because we have already studied the, if you do the sensitivity analysis, the order quantity will not affect greatly your the total cost. So, now what we got from the lead time demand, we have found that annual demand is 8008 units per year. Now, we have to decide how much to order. So, although we are in a probabilistic demand situation, we have an estimate of the expected annual demand of 8008 units. How we have got this 8008 units? We know the weekly demand during the lead time, that demand we have multiplied by 52. So, we got now annual demand. Now, we can apply the simple EOQ model as an approximation of the best order quantity. So, the model which we are discussing is an approximation of the best order quantity with the expected annual demand used for the D, used for this distributor. So, what are the data is given? Annual demand is given. So, annual demand is 8008, this is 8008. Ordering cost is 12, holding cost is 1.2. So, we know our traditional formula 2D C naught by CH, C naught is the ordering cost. So, 12, CH is the holding cost, we know the demand. So, it is 400 units. So, for a multi-period probabilistic model, the optimal order quantity is 400 units. You remember when we studied the sensitivity analysis of the EOQ model, we learned that the total cost of operating an inventory system was relatively insensitive to the order quantities that were in the neighborhood of Q star. You remember when we are doing sensitivity analysis. So, this will be your holding cost, this will be your ordering cost. So, this will be your total cost. So, the total cost at a particular point is a flat. So, this flat indicates that even though your Q is increased by or decreased by some quantity, the net effect on the total cost, this is the total cost, this is your holding cost, this is your ordering cost. So, what will happen even though there is a slight changes in the ordering quantity. So, the total annual inventory cost will not be change. Okay. So, using this concept of sensitivity analysis, we expect 400 units per order to be a good approximation for the optimal order quantity. Even if annual demand were as low as 7,000 units or as high as 9,000 units, an order quantity of 400 units should be relatively good low cost order size. Thus, given our best estimate of annual demand at 8008 units, we will use the optimal order quantity is 400. Now, we got the answer for how much to order decision. So, we have established that 400 units order quantity by ignoring the fact that the demand is probabilistic. Using Q star optimal order quantity equal to 400, distributor can anticipate placing approximately how many orders? D by Q. So, D is 8008, Q star is 400. So, he will be making 20 orders per year. So, we got the number of orders. So, we got Q star 400, we got number of order how much 20, and assume that industry that distributor operates 250 days per year. So, when you divide this 250 days by 20, that is number of orders, so the 12.5 working days between the orders. So, the order cycle is 12.5 working days. What is the meaning of that? Every 12.5 working days he has to make a order. How much to order? He has to order 400 units. Now, we got the answer for how much to order. The next point is when to order decision. So, when to order decision is we need to know the reorder point. We know we now want to establish a when to order decision rule or reorder point that will trigger the ordering processes. With a mean lead time demand of 154 units, you might first suggest 154 units reorder point, because the lead time demand is 154, that is average lead time demand. You may think that you can order 154 units. However, considering the probability of demand now become extremely important, because the probability of demand is changing, there is a chance that the demand may increase more than 154 units during the lead time. Okay. So, if 154 is the mean lead time demand and if the demand is symmetrically distributed about 154, then lead time demand will be more than 154 minutes, roughly 50% of the time. So, we know that see this is mean 154. So, this side probability is 0.5. So, that means what? For weekly demand is 50% of time the demand will be less than the mean. So, remaining 50% of time the demand can be more than 154. So, whenever suppose if you order 154 units, so 50% of time the demand may increase. So, what will happen? You will end up the stock out. So, when the demand during the 1 week lead time exceeds 154 units, the distributor will experience a shortage or stock out. Thus, using a reorder point of 154 units, approximately 50% of the time, that is 10 of the 20 orders a year on average, the distributor will be short of bulbs before new supply arrives. So, we should not go for 154. See 154 50% of time out of 20 orders. So, 10 orders 10 times you will come out with the shortage. So, this shortage rate would most likely be viewed as unacceptable. So, we should not order 154. So, given this distribution, we can now determine how the reorder point R affect the probability of stock out, because the stock out occurs whenever the demand during lead time exceeds the reorder point. We can find the probability of stock out using the lead time demand distribution to compute the probability that the demand will exceed the reorder point. So, we have that reorder point demand. What does that mean? Is 154, standard deviation is 25. Now, by knowing this information, we can find out the probability of stock out. Otherwise, the probability that the demand will exceed the R is here reorder point. Now, we are going to find out if there is a stock out, what is the cost per stock out. Okay. We could now approach the when to order problem by defining cost per stock out and then attempting to include this cost in a total cost equation. So, we know that suppose if they order 150, if the demand goes beyond the reorder point, there will be a stock out. We can assign some cost for each stock out. Like this, we can find out the annual stock out cost. So, alternatively, we can ask the management to specify the average number of stock outs that can be tolerated per year. So, we can ask how many number of stock out the company can tolerate. If your demand for a product is probabilistic, a manager who will never tolerate a stock out is being somewhat unrealistic, because attempting to avoid stock out completely will require high reorder point, high inventory and an associated high holding cost. Since the nature of the demand is probabilistic, so the distributor can tolerate some stock outs. So, he cannot say that I do not want any stock out situation, because going for not having any stock out situation is highly costly decisions, because we need to have more inventory, there will be more holding cost. So, that is not good. So, what I am trying to say is that since the demand is probabilistic in nature, the buyer, the manager have to tolerate certain stock outs. Suppose in this case the management of the distributor is willing to tolerate on average one stock out per year. You remember that we are making 20 orders, okay. Because the distributor places 20 orders per year, this decision implies that the management is willing to allow demand during the lead time to exceed the reorder point one time in 20. So, 1 upon 20 times they are allowing for stock out. That means the demand, the lead time demand is exceeding the reorder point. You take care during editing. The reorder point R can be found by using the lead time demand distribution to find the value of reorder point with a 5%. When I say 1 by 20, it is a 5%. So, 5% of time they are willing to tolerate the stock outs. Okay. So, that means what? The lead time demand distribution to the reorder point R can be found by using the lead time demand distribution to find the value of reorder point with a 5% chance of having lead time demand that will exceed it. You see that, look at this side, this picture. So, 5% of time, okay, the demand can exceed the reorder point. Whenever the demand exceeds the reorder point, there is a stock out. So, the company is willing to wait 5% of time, they are willing to accept the stock outs. So, look at this situation which is shown in graphically. Now, we should know this Z value here, R value. The probability, how to calculate the probability of stock out? So, the probability of stock out during any one inventory cycle is easiest to determine, easiest to estimate by first determining the number of orders that are expected during the year. For example, here we have found 20 orders. The inventory manager can usually state willingness to allow perhaps 1, 2 or 3 stock outs during the year. In our problem, the manager is willing to tolerate 1 stock out. So, the allowable stock out per year, that is 1 allowable stock out per year divided by the number of orders, say 20 equal to will provide the desired probability of stock out. So, 1 by 20 is 0.05, that is 5%. Now, we will find out the reorder point. Okay. So, what we know that? We know that, so this side area is 0.05, 5% is stock outs. So, what is this side? The remaining is, so when you, so 0.05. So, now we have to find out this reorder point. Okay. What is the mean of this distribution? Mean is 154. What is the standard deviation of this distribution? 25. So, mu equal to 154, sigma equal to 25. Now, we have to find out what is the R point. This R we are going to do with the help of Excel. We know that in Excel there is a function. So, there are two functions equal to norm dot inv is there, otherwise norm dot s dot inv. So, S means standardized normal distribution. So, norm the inv means for any distribution. So, we can use any formula to find out what is the reorder point, the value for the reorder point. So, now I will open Excel, I will explain how to find out the reorder point. So, equal to n norm dot inv. So, you see the because the right side area is 5%, so left side area is 0.95, 0.95, mean is 154, standard deviation is 25. You see that the reorder point is 195. There is other formula, instead of using this formula, norm dot s dot inv, probability is 0.95, 95. Okay. So, the value of z is 1.65. You see that. So, we got the z value is 1.65. We know this formula z equal to x minus mu by sigma. Since see the value of z is positive right hand side. So, 1.65 x we do not know, the mu is 154, sigma is 25. So, from this expression we can find out value of x. So, the value of x will be 195. So, both way we can find out the reorder point. What are the both way? There are two formula in Excel. One is norm dot INV, otherwise norm dot S dot INV. Okay. Now, I will go back to the presentation. So, the recommended, you see that inventory decision is to order 400 units whenever the inventory reaches the reorder point of 195. So, how we got this 195? Just now I have shown this. The generic formula is R equal to mu plus Z sigma, but this is not something new. We know that this is our traditional x minus mu by sigma. So, here x is nothing but your reorder point. So, when you readjust this, what will happen? X equal to mu plus Z sigma. That is why this formula has come. Because the mean or expected demand during the lead time is 154, we are ordering 195. So, 195 minus 154, this 41 units serve as a safety stock which absorbs higher than usual demand during the lead time. Roughly 95% of the time, the 195 units will be able to satisfy the demand during the lead time. That is the meaning of this side area 0.95. Okay. Only 5% of time we may not be able to satisfy the demand, but that is also accepted by the company or managers. So, now we can find out the anticipated annual cost. First cost is holding cost for normal inventory. What is the traditional formula? Average inventory multiplied by holding cost. Average inventory is Q by 2, 400 by 2 multiplied by holding cost is $240. Now, the safety stock. Remember that apart from 154 we are having 41 units additional unit. So, that stock also we have to pay the holding cost. So, 41 multiplied by 1.2 is $49. What is the ordering cost? Number of orders multiplied by cost of ordering. So, number of order is 8,800 by 400 multiplied by 20 is the ordering cost. So, the total annual cost is 529. Only additional cost we are incurring due to probabilistic demand is this safety stock. So, the safety stock is how much? $49. If the distributor could assume that a known constant demand rate of 8,000 units per year existed for the light bulbs product, the optimal order quantity will be 400, reorder point will be 154 and the total annual cost will be how much? 240 plus 240 only 480. When this will happen? When the demand is constant demand, but that is not the case here. Here the case is the demand is probabilistic in nature. When the demand is uncertain and can only be expressed in probabilistic terms, a larger total cost can be expected. The larger cost occurs in the form of larger holding cost because more inventory must be maintained to limit the number of stockouts, right. This additional inventory or safety inventory stock was 41 units for our problem. So, because of this 41 units we are paying additional annual holding cost is $49. Assume that we remember that we assumed the demand during lead time is normal distribution. There may be some other distribution the demand can follow during the lead time. If that is the case, the whole problem will be completely different. But since the normal distribution is a common approximation for any distribution, even though the demand may be any distribution, you can assume a normal distribution. At the end there will not be much variation in the total cost. Now we will take another sample problem. I will explain this concept with the help of one more problem. A company provides a variety of auto parts to small local garages. Company purchases parts from manufacturer according to the EOQ model, then ship the part from a regional warehouse direct to its customers. Traditionally they follow EOQ model, where the constant demand rate. For a particular type of muffler, that is an automobile component, the company's EOQ analysis recommends order that Q star equal to 25 to optimal order quantity is 25 to satisfy an annual demand of 200 mufflers. The company has 250 working days per year and the lead time average is 15 days. What is the reorder point if the company assumes a constant demand rate, our traditional EOQ? Suppose that analysis of company's muffler demand shows that the lead time demand follows normal probability distribution with the mean 12 and standard deviation 12.5. If the company's management can tolerate one stock out per year, what is the revised reorder point? The second case, what is the safety stock? If the holding cost is $5 per unit per year, what is the extra cost due to the uncertainty of demand? So, this problem is a multi-period problem, the demand is probabilistic. So, there is a lead time. So, we are going to find out the when to order and how much to order. The first question is, what is the reorder point if company assumes a constant demand rate? We know that the reorder point is demand during the lead time. So, what is a per day demand? We know the annual demand is 200, assume that the company operates for 250 days. So, 200 would have a number of days, you will get a per day demand and lead time in 15 days. So, when you simplify, the reorder point is 12 units. Suppose that analysis of company's muffler demand shows that the lead time demand follow normal probability distribution with the mean equal to 12 and standard deviation is 2.5. So, this is the mean time, this is our standard deviation. If the company's management can tolerate one stock out per year, okay. So, they are willing to tolerate one stock out per year, what is the revised reorder point? First we have to find out the reorder, the stock out probability that they can tolerate. For that we should know what is the number of orders. So, number of order is equal to D upon Q star. So, Q star we got already, it is given in the problem 25. So, 200 divided by 25, it is 8 order per year. Okay. The limit of one stock out per year means that what is the probability of stock out? 1 upon 8. So, 1 upon 8 is 0.125. So, this area is 0.125. Now, with the help of Excel, we are going to find out what is the reorder point. So, first we should know the right side area. What is the right side area? 1 minus 0.125. Keep. So, we should know this left side area, that is equal to 1 minus 0.125. So, this area is 0.875. Now, open equal to norm dot inv, probability is 0.875, uh, 12 comma 2.5, yes, close this. So, it is 14. So, this mean is 12. So, it is coming 14.87, approximately 15 units. I will go back to the presentation. Now, the reorder point is 14.875, approximately reorder point is 15. So, what is the safety stock for part B? What is the meaning of safety stock? In case the demand is not fluctuating, we will order only 12 units, but now the demand is fluctuating, instead of 12 we are ordering now 15 units. So, the safety stock is 15 minus 12 is equal to 3. So, the holding cost for each unit is 5. So, the total cost is safety stock cost is $15. Dear students, in this class I have discussed about multi-period order quantity reorder point model with the probabilistic demand. So, I have taken two problems. With the help of these two problems, I have discussed about how much to order and when to order. The next lecture we will be discussing about periodic inventory system. Thank you very much.